Time, position, velocity. A helium balloon is released from the top of a building. The graph shows the altitude of the balloon over time. So have a close look at the graph. So along the horizontal axis, we are showing time in seconds. Each division is 1 second. Along the vertical axis, we are showing altitude or the height of the balloon in meters. And here each division is 5 meters. It is marked 10, 20, 30, 40, 50 as 2 divisions, right? Now after studying this graph, you need to answer these questions. So question number 1 is, how tall is the building? Question number 2 is, what was the altitude after 2 seconds? Question number 3 is, when did the balloon reach altitude of 45 meters? And question number 4 is, what is the balloon's velocity, right? So I'd like you to answer these questions, go through the graph, stop the video, and then look into my solution, okay? Here is my solution. So in this graph, what are we showing? We are showing a helium balloon is released from the top of the building. So the starting point is top of the building, correct? The graph shows the altitude of the balloon over time. So we are showing altitude means height of the balloon over time after it is released from top of the building, right? So the answer for question number 1 should be, how tall is the building? So at t equals to 0, that means this is your starting point. What is the altitude or the height? So it is 25, correct? So this point A is the point from where the balloon is released, right? So we can say altitude represents the height of the building, right? Because the balloon is released from the top of the building, correct? Therefore, the building is 25 meter high, right? So we'll write 25 meter here as height of the building, right? Now, question number 2 is, what was the altitude after 2 seconds? To find altitude after 2 seconds, what we can do is, we can go to the time scale 2, right? And draw a vertical line. So 2, it strikes the graph at a point, let's call this point as B, and then read the altitude after 2 seconds. It is 35, correct? So we get, what was the altitude after 2 seconds? It is 35 meters, right? So we get 35 meters here, right? Now, question 3 is, when did the balloon reach altitude of 45 meters? Let's go to this altitude scale. 45 is here, right? So we can draw a horizontal line from 45. So it crosses our graph at C, right? C is the point which signifies altitude of 45 for the balloon. When did it happen? So it'll come down. So we go in this direction, right? Because we are given 45, and then we are going downwards to find when did it happen. So it is at 4 seconds, right? So when did the balloon reach the altitude of 45 meters? We get our answer as 4 seconds. So the answer is 4 seconds. Now, question 4 is, what is the balloon's velocity, right? Now, how will you find velocity? So all those things which from question 1 to 3, you could straight away read from the graph, right? Graph is showing altitude, which is the height in this case of the balloon, with time, and they were related with height and time, right? Or the altitude or time. So you could straight away read from your graph. But how will you find velocity? Now velocity is slope, rate of change of altitudes with time. That is what the velocity is, right? So to find velocity, you can consider any 2 points. We have already seen that for a straight line, velocity is same, right? It's a constant velocity. It doesn't matter which 2 points you consider. So you could consider any 2 points. So let's consider point A and point C. Now what is the position at C? The position is, first we write the horizontal, which is 4. 4 seconds, and then the height, which is 45. And for A, the position is 0 and the height is 25, right? So what is the slope here? So let me calculate slope here. So let me first make a triangle, correct? So our triangle will be, here is our triangle, correct? So rise is from A to C, right? So rise is 45 minus 25. The difference in y values in proper order is 45 minus 25. And divided by run, which is change in time, which is from 4 to 0. So it's 4 minus 0, correct? So 45 minus 25 is 20. And 4 minus 0 is 4, right? So 20 divided by 4, which gives us 5 meters per second, right? So every second it is going up by 5 meters. So what is the balloon's velocity? Balloon's velocity is 5 meters per second. And that is how we calculate it, correct? So how did we calculate? Velocity is slope, right, between any 2 points. So we can write slope, which is, let me write here, slope, or rate of change, or we could say rate of change, right? Rate of change of what? In this case, rate of change of altitude with time. So that is what velocity is. And how did we calculate? We took any 2 points. You could have taken A and B. A and C is better. Longer distance will give you more accurate results, right? Here it is a whole number and therefore you get the same answer. But sometimes when there are fractions, in that case, if there is bigger triangle, you get more accurate results, right? So slope or rate of change of altitude with time gives us the velocity of the balloon. And here we calculated, we just took 2 points, 2 positions, right? So one was A, the other one was C. A was the initial point whose coordinates are 0, 25, and C was a point which was 4 seconds away, right? The coordinates are 4, 45. Rate of change is rate of change of altitude. That means change of altitude divided by change in time. Altitude changes from 25 to 45. So it is 45 minus 25. And change in time is from 0 to 4. So final is 4. So 4 minus initial, right? So it is final minus initial. Final minus initial. Order should be maintained. So we get 20 divided by 4, which is equals to 5. And therefore, we got a velocity of 5 meters per second, correct? So that is how we are going to do such word problems. Reading and providing information from the graph. It is a very important application of all the graphs, and that's the whole purpose. A picture gives you a lot more information of things happening, right? So that's the beauty of the graph. Thank you. I hope you appreciate it.